Mr. Jessel, how do I find X-intercepts?
Oh, it's really not that hard. You can use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac and all over 2a. See? It's as simple as that.
When am I going to use this in real life?
And that's when I thought to myself, when are my students going to use math? I mean, I use math all the time, but I'm a math teacher. But wait, a lot of my friends are successful professionals. I could ask them how they use math.
My name is Stealth Olvang. I am a musician. I normally, when there's not a pandemic, I tour with the band The Lumineers.
My name is Baria Malas, and I am substation engineer and designer for Excel Energy.
My name is Ian Kramer, and for work, I've been in sales for 7 years, but for fun, I've been climbing all of the tallest mountains in Colorado.
I finished high school, almost dropped out, didn't, and then I went to school for music and then dropped out, and then I went to school at a different school, UNC Colorado, tried to get into the music program, and I dropped out.
I finished high school in Saudi Arabia, and then I moved to Syria, which is my country, and I finished in Syria college. I have bachelor's in art of architecture, so I'm an architect. That's my college.
I finished high school and graduated college with a degree in English and philosophy. So I went right from high school into four-year college, graduated, and did not go back to school after that.
Tons of ways, but where to start? I mean, as a musician, I think that's the obvious answer. Is music is completely mathematical. Time signatures are mathematical, and patterns. Just like, I don't know, everybody who is probably watching this knows music and understands rhythm and listens to music, be it from classical music to hip hop. You hear just like the patterns and the rhythms. Pretty much all tones are divided by 12, scales before they get doubled, stuff like this, which I use actively when I'm using a tuner, or even when I'm checking my piano tuning with my guitar as I'm tuning that. So that would be the obvious answer. The unobvious answer is how much time I spend calculating mileage in between cities when we're on tour. It's constant. And I am constantly being like, okay, our bus travels only about 60 miles an hour at night, a pretty big bus that we're on. I know that New York City is, 180 miles from where we are. We won't get into New York. Maybe New York City is a bad example because of traffic. But let's say Cincinnati and Louisville are about 250 miles apart or something. Then you can calculate, okay, I'll probably be showing up there at about 4 a.m. I'm not going to want to get off the bus. Every single night I'm doing these calculations. Just really quick multiplication of, our 60 mile an hour bus times however, or, divide that by how many miles away the place is. Google Maps constantly.
How do I use math? First of all, I play Sudoku, It's full of numbers. Here you go. I use it every day, really, with my job. I do design things. So designing a substation. So substation is a land, and it's full of equipment. These equipments provide electricity to the houses. So to design the substation equipment, I need to know where I'm placing these equipments and what is the distances for each one to the other one. Or let's say, for example, we start with what we need, area or space. So if we know how to calculate the space, we should be able to calculate this in math, right? If we don't know how to do that, then we are not going to know if these equipments that we have 1, 2, 3, 4 would fit in this area or not. This is like the simplest first thought that we think about when we have a substation. This is my job. So for each equipment, it has also surrounding to be safe, so these equipments don't blow up. If they are so close to each other, with the electricity, they're gonna blow up, right? So if we put 2 transformers that they change the voltage, let's say from high voltage 230 to lower 115, if we put them close to each other, with this much of electricity, they will just blow up. And then we will have a blow up area. And that's fun. So that's how I use math in my work. It's what actually helped me here when I came here to the US. Like I knew math before I know English. So when I'm talking to somebody, it's like I can talk to them in math because I know math, but I don't know how to talk English. And just for us, like I did apply for college, and I did AccuPlacer test. So this test has like a half of it math and the other half is English. In math, I got 100%. And in English, I didn't pass. And they told me, how did you exactly answer these questions in math, which they are in English, and you couldn't like understand the English? But because math is like universal, international, everybody, it's the same laws everywhere. It's not just like a language of the US. It's a language the same in Europe, the same in Syria and everywhere.
I think my favorite way to use math in my life is when I'm planning for really big mountain hikes. In Colorado, our tallest mountains are 14ers. So those are mountains that are 14,000 feet or taller. And I've climbed all those. And now I'm in the process of climbing all the 13ers. So those are all the mountains that are 13,000 to 13,999 feet. There's 584 of those and 764 if you're including all the ranked and the unranked mountains. So it involves a lot of time measuring distances, and that can be really difficult just because there's so many ups and downs in the backwoods, and those contours are not always calculated on these different maps and the different tools that are available. So oftentimes what looks like only 12 miles on a straight line on a map can actually turn out to be more like 15 or 16 with all the twists and the turns and like the obstacles that are in the way. I also have to calculate elevation gain. So that is another tough challenge. And it usually involves somewhere between 3,000 and 10,000 feet of elevation gain. So it's figuring out how much am I gaining? And then usually it's because it's from point A to point B, I have to turn around and get back to point A. So not only do I have to calculate all the elevation to get there, but then calculate how much, double that to get back. If I'm taking the same route, if I'm taking another route back, then it's a whole another set of calculations. So to do that, I use multiple maps and GPS tools to figure out what my distance and what my gain is going to be. And then I basically just double it from the summit that I'm trying to reach. And once I know those figures, I can calculate how long it's going to take me. So for example, I know I move about 2 to 2.5 miles per hour downhill. and about 1 to 1.5 miles per hour uphill. So hikes can take anywhere between like 6 and 20 hours, depending on how far I'm going and how high I'm going to be getting into, the mountains and where I'm headed to. So it's a lot of math and a lot of prep. But once I have all that information, it makes the hike so much easier, just mentally, just getting over the challenge of this is what I have to do today, and physically, because then I can kind of prepare myself for what I'm heading into and what kind of adventure I'm about to have. Just recognize that math can show up in really funny and unusual ways in your life, and can end up being one of the most important parts of either your passion or your job. So keep that in mind, find something that you love in math. And if you love math, you're going to do great. Math shows up everywhere all the time in adult life.